Okay. We are picking up where I believe we left off yesterday, where we were starting to practice with multiplying binomial radical expressions. We are multiplying these binomials. Basically, we said, what are we doing that you already know how to do? We are foiling, right? You're already familiar with foiling, and that's what we're doing. Okay, so while I was getting attendance, I asked you to attempt B. So, as we go about looking at this, first step, what do I do on B? Okay, we're foiling. First is we take the 3 and distribute it to the 2. And 3 times 2 is going to be 6. Okay. Then outsides. I take the 3 and I'm multiplying 3 times 4 square root of 5. Multiply outsides with outsides, square roots with square roots. 3 times 4 is going to be 12. And the square root of 5? So that's going to be plus 12 square root of 5. Then we're going to do our insides, or we're going to take the negative square root of 7 and multiply it by 2. What is negative square root of 7 times 2?
Negative 2 times the square root of 7.
Yeah. 2 stays outside. 7 stays under the square root. Positive times negative. So negative 2 square root of 7. And then last, I'm taking the negative square root of 7 and distributing it to 4 square root of 5. My outside pieces, it's a negative times a 4, which is going to make it negative 4. Square root of 7 times square root of 5. Square root of 35. Okay. What's my next step?
You can't do anything.
Clean it up.
Okay. My next step should be to clean it up, but does anything clean up and simplify?
No.
What did we learn yesterday? In order to add radicals, the radicals have to be the same. So I can add a square root of 5 to another square root of 5. But I only have one square root of 5. I could add a square root of 7 to a square root of 7 term. But I only have one square root of 7. I could add a square root of 35 to square root of 35, but I only have one square root of 35. So in this case, it's not that we couldn't do it. We did multiply. We just can't go any farther. So we're going to stop there. Okay? Does that mean you're going to be big pros on C by this point?
Sure.
No.
Worth a shot, right? Okay, where do I start? Okay, 3 times 2. 3 times 2 is 6. Okay, then what do I do with the 3? Three times 4 square root of 5. Multiply outsides with outsides, square roots with square roots. So 3 times 4 is going to be 12. And then we just keep the square root of 5. And we're going to do insides. 2 square root of 5 times 2. Yeah, regular numbers with regular numbers. So 2 times 2 is 4. And then square root of 5. And then last, 2 square root of 5 times 4 square root of 5. Whole numbers times whole numbers. Square roots times square roots. 2 times 4 is 8. Square root of 5 times square root of 5. Square root of 25. Do I get to quit on this one as easily as I did the last one?
Sadly, no.
Okay. This one makes you think it's more like a normal problem, though. You don't get to the end, you're like, wait, what did I do wrong? Can I, what am I supposed to do? You know what to do here. Okay. As of right now, the 6 is just a whole number 6. Do I have any other whole numbers it goes with? No. So that 6, just going to carry down as a 6. What do you notice about these two middle ones? Yeah. So if we have 12 square root of 5 plus 4 square root of 5, what's 12 of something plus 4 of something?
16.
16 of something. And so that is plus 16 square root of 5 plus,
8 square root of 25.
but what do we know about the square root of 25?
5 is 5. So
Ooh.
it is
Now, some of you already, when Justin said square root of 25 earlier, did some of you automatically say 5 possibly? You may have. So you may have already said, oh, I know this is 8 times 5. If not, make sure you take it now. That's a perfect square. Square root of 25 is 5, and 8 times 5 is 40. Am I done?
no.
No,
Clean it up.
because now we have another cleanup, don't we? 6 plus 40 is 46 plus 16 square root of 5. What is 46 plus 16 square root of 5?
46 plus 16 square root of 5.
Okay. I'm done here, right? I'm going to keep trying to trick you. You've got to get past my tricks there. I can't add them because one has a square root of 5 and the other does not. Okay. This is foiling. You guys already knew how to foil. Now, when we look at this next row, it's asking what is the product of each of the following. It says multiplying conjugates. I feel like we've used the word conjugates in this class already this year.
Yeah.
We have?
Yeah.
Okay. Do you remember what a conjugate is?
No.
It's when it's like the same, it's like a minus and then a plus, so then it just cancels.
Okay. So conjugates, when we talk about binomial, same values. The piece that's different is the middle sign. So just one sign difference. Not both sign differences, just one. Now, how do you think we multiply 5 minus square root of 7 times 5 plus square root of 7? We're going to FOIL again? Is it a binomial times a binomial?
Yep.
Yeah. Here's the deal, though. Because they're conjugates, good things will happen. Okay? So, let's practice here. What's first?
5 times 5.
5 times 5 is 25. Then what do I do with that 5?
Multiply it to the square root of 7.
Okay. And what is 5 times the square root of 7?
5 times
Good. 5 square root of 7. I hear multiple people answering. That's good. Then we take negative square root of 7 and repeat the process. Negative square root of 7 times 5?
negative 5 square root.
Negative 5 square root of 7. And then negative square root of 7 times positive square root of 7. Not 0.
Negative square root of 49.
Okay? Negative square root of 49, if you will, because square root of 7 times square root of 7 is square root of 49. Can I continue? Yes, I can. What is the obvious piece that stands out to you? Yeah. What happens to my middle here? 5 square root of 7 minus 5 square root of 7. If these are conjugates, which they were, and we did things correctly, Those cancel. So that leaves me still with a 25. And that leaves me with a minus, if you haven't already, the square root of 49 is 7. And 25 minus 7 is a number. Really? You guys are slacking on me here. 25 minus 7 is 18.
You can't count me wrong on a test if I put that, can you?
Oh, yes, I can.
Darn it. But I'm not wrong. Then I'm not right, but I'm not wrong.
It's just those answers.
Notice what you said. You're not right. So,
Yeah, but I never said no.
okay. So, key thing to notice here, guys. When you multiply by the conjugate, your middle terms will cancel out. And usually when you multiply conjugates, your answer will become just a whole number. Okay? When you multiply by conjugates, the whole idea is that we'll no longer have square roots. It'll just be a whole number. Let's practice B. We may or may not practice C. We'll see. Okay. What's first? Six times 6? 36. Then what do I do with that 6? Yeah, 6 times the square root of 12 is 6 square root of 12. Now, negative square root of 12 times 6. Negative 6 square root of 12. Okay, and lastly, negative square root of 12 times positive square root of 12. Your shortcut here would be to say minus 12, wouldn't it? Now, I'm all about that. If you'd prefer, if you're not comfortable with that, and you're still at the, nope, I multiply and then I do the square root, whatever floats your boat. Okay? So, minus square root of 144. Did we have similar pieces happen this time? Six square root of 12 minus 6 square root of 12 will cancel. I still have 36, and we already talked about minus the square root of 144 is minus 12. 36 minus 12 is 24. Okay. Are you getting tired of foiling yet?
Yeah.
No.
Okay. Well, have you guys gotten C done?
No.
Because I was going to move on to the bottom part, because guess what? We're not done with foiling.
Darn it.
We're still going to foil more on the bottom part. So, if you're working this one, I'll tell you the right answer there. Okay? I personally am going to move to the bottom row. Or should I give you a moment to make sure you can get that answer? I see some of you working. Is it working out for you if you're trying it? If I write it out real quick for you so you can check your steps. There's the first line you should have gotten, in case your answers aren't working out for you. So, Okay, start looking at this bottom row. We spent all this time multiplying, and now we're ready to divide. As you look at that bottom row, you start thinking about dividing. Realize we're not actually going to divide, though. Okay. No. When it's asking for what is the simplest form, notice it says rationalizing a denominator. We did some rationalizing the denominator, I say in 6.2, is that when it was? When we were trying to just, if there's a square root of 3 on bottom, we multiply by square root of 3. Well, now, when there's adding and subtracting to rationalize the denominator, we just learned how to multiply conjugates, right? So guess what? In order to rationalize the denominator, we're going to multiply by the conjugate. So that is going to be our trick here, to multiply by the conjugate. Now, when I say multiply by the conjugate, I guess I should put in there, it's the conjugate of the denominator. So as we look at A, 3 square root on top, square root of 5 minus square root of 2 is on bottom. What do you think the conjugate of square root of 5 minus square root of 2 is?
Square root of 5 plus square root.
Okay, remember conjugate, we just changed that middle sign. So conjugate is going to be square root of 5 plus square root of 2. You guys are well trained with fractions, right?
No.
If you multiply the denominator by square root of 5 plus square root of 2, we're going to multiply the numerator by square root of 5 plus square root of 2. On top, am I foiling on top?
Not exactly.
I'm not foiling on top because 3 square root of 2 is just one term. So we just need to take that 3 square root of 2 and we need to not add it, multiply it. We're going to distribute it. So 3 square root of 2 times square root of 5. Start there. What is 3 square root of 2 times square root of 5?
3 square root of
3 square root of 10 plus, what's 3 square root of 2 times square root of 2?
3 square root of 4.
Okay, 3 square root of 4. Denominator. What do I have to do with the denominator now?
No.
We wish.
Oh.
We're going to have to FOIL, aren't we? Okay. The denominator, you're multiplying by the conjugate. This is FOIL. So, square root of 5 times square root of 5.
Square root of 25.
Square root of 25. Square root of 5 times square root of 2. Square root of 10. Minus square root of 2 times square root of 5. Minus square root of 10. Minus square root of 2 times positive square root of 2. Minus square root of 4. Okay. We got some cleanup to happen here, don't we? Couple of things before I start writing stuff out. In the denominator, what do you notice? These are conjugates, right? Your middle term should cancel. Square root of 10 minus square root of 10 will cancel. What do you know about the square root of 25?
It's 5.
So this is going to be a 5. What do you know about the square root of 4?
It's 2.
It's going to be a 2. What do you know about this square root of 4 up here?
It's also 2.
So is there some cleanup I can do? Definitely. And that's the whole idea. Because remember, we can't have a radical in our denominator in the end. So we've got to do some serious cleanup here. On top, 3 square root of 10 is still
3 square. Yeah. 3 square. Yeah. I'm done talking.
okay. 3 square root of 10.
Spit it out, Justin.
I can't.
What about 3 times the square root of 4? Becomes 6, right? Because square root of 4 is 2. So if you haven't already done this, 3 times 2 is 6. Okay, denominator. My square root of 25 becomes 5. Square root of 10s are gone. And it's minus square root of 4 becomes 2. I went ahead and wrote that step. Some of you might be like, really, Mrs. Sargent, you didn't go ahead and subtract the bottom? I did not. Feel free to go ahead and subtract on your own. Okay, keep going. My numerator, can I add 3 square root of 10 and 6?
No.
No. So they're going to say 3 square root of 10 plus 6. But 5 minus 2 is 3. Good news. No radicals in the denominator. Can I go a little farther?
You can divide 6 and 3.
And 3 and 2.
So here's the deal. If we can go farther, this denominator of 3 has to be able to divide into both terms on top. 3 does divide into 6, doesn't it?
Yeah.
And 3 divides into this 3 out in front of the radical.
Yes.
It has to be able to divide into both terms to do this. Otherwise, if it only divided into the 6, we'd have to stay here. But since this 3 divides into the 6 and into the 3 square root of 10, I'm going to go one more step. 3 square root of 10 divided by 3 is just going to become square root of 10. Plus 6 divided by 3 is going to become 2. So square root of 10 plus 2. And you could also say that is 2 plus the square root of 10. Okay. We have time. I could take time for all 3 of these, but I feel like it'll get repetitive. I had planned on doing C. I can tell you the answer for B.
Okay.
But then I think I'm going to go ahead and skip to C. Although we have time, maybe I should. Well,
And
if we decide we want to come back to this one, we can. Your middle one ends up being negative square root of 21 minus square root of 35. That's for checking purposes. If you are a Mrs. Sargent, you can't leave me hanging on what the answer is. There's your answer, right? Ready to try C with me?
sure.
Okay. C, notice what I have in the denominator. I have a square root. I can't leave square roots in the denominator. So how do I get rid of this square root in the denominator?
Multiply it by the conjugate.
Okay. We're going to multiply by the conjugate. What is the conjugate of 3 minus square root of 6?
3 plus square root.
3 plus square root of 6. If I multiply the denominator by 3 plus square root of 6,
Let's go.
we're going to multiply the numerator. Now realize it is possible sometimes you might have to FOIL in the numerator. That is possible. It's just not happening in our examples right here. Notice there's an x thrown in. You can still work with that, right? We can still multiply with an x. So on top, I'm going to take this 4x and I'm going to
Multiply it to the
I'm going to distribute. 4x times 3 is 12x. 4x times square root of 6.
4x times square root of 6.
Okay, 4x square root of 6. All over. Okay, denominator, we need to FOIL or distribute. 3 times 3. 9. 3 times square root of 6.
3
3 square root of 6. Now, negative square root of 6. So negative square root of 6 times 3. 3 times square root of 6 is just still 3 square root of 6. It's just positive times negative, so negative this time. And negative square root of 6 times square root of 6. You can say minus square root of 36, or you could go ahead and say minus 6. I don't care what you write on your papers at that point. Okay, let's see. Clean up. Is there anything I can do on top? I can't take the square root of 6. I can't add 12x and 4x because 4x is attached to the square root. So my numerator is staying as is. 12x plus 4x square root of 6. Denominator. Well,
3 square root of x's cancel.
I mean 3 square root of 6's?
Yeah.
Okay, 3 square root of 6 minus 3 square root of 6. Gone. What about the square root of 36?
6.
That's 6. What about 9 here? It just stays 9, yes? No one's going to fall for, oh, I'm going to take the square root of 9? It doesn't say to take the square root of 9, does it?
No.
So we have 9 minus 6. And what do you know about 9 minus 6? 3. So I have 12x plus 4x square root of 6, all divided by 3. It is an option for a final answer. And here's the deal. 12 divides by 3, doesn't it?
Yes.
4 doesn't.
But 4 does not. And 6 doesn't matter because it's under the square root. So
what's the other option?
okay, the other option, and I'm trying to remember why I have this written in my notes. I don't necessarily know if it comes up in Math Excel and you have to do something about this, but the other option you will sometimes see, a denominator of 3, is they will sometimes take that denominator of 3 and factor it out front as 1/3. And so then they'll say 1/3 times 12x plus 4x square root of 6. That is the other equivalent option. And I can't remember if there's something that comes up in Math Excel, which is why I wanted to introduce this. I can't remember. I didn't look back to see. But I'm perfectly happy with the first one. I just want you to be familiar with the second one. Okay? Your homework that you should be spending a few minutes of time working on right now is lesson 6.3 in Math Excel.